Hi everyone, I'm Akash Sane, a co-creator of the project template on sea level rise. Sea level represents the average location of the interface between the air and the ocean. It serves as a reference for measuring the elevation of surface features such as hills and mountains and buildings. It is important to note that sea level varies geographically and can be influenced by several factors, including currents, winds, river flow at estuaries, and storms, as they transport water masses between different locations. This image shows sea surface anomalies, and we can clearly observe the variations in different regions of the oceans. Sea level is primarily rising due to climate change, with the dominant cause being the volumetric expansion resulting from the warming of seawater and the addition of water from the melting of ice sheets and glaciers. As the ocean warms up, it starts getting heated from the surface and slowly the heat spreads to its depths. Addition of heat lowers the density and increases the volume of deeper regions of the ocean, giving rise to increase in the sea level. Understanding these processes is crucial as coastal communities and ecosystems are vulnerable to these changes. Scientists are confident that the rise in sea level is attributed to human induced climate change, and they employ data from diverse sources to study and predict these changes. In this project, you will explore sea level rise using the ECHO product, which you might be familiar with from the tutorials. ECHO stands for Estimating the Circulation and Climate of the Ocean, and it is a product created by integrating ocean model data with observations. Within the provided ECHO dataset, the variable which represents sea surface height is denoted as SSH. This variable is already processed and can be directly used for analyzing and plotting sea level. The model data, uh, uh, the echo data can also be compared with data from tidal gauges. We have also we have provided some references as a starting point to further guide you into developing your own questions and their answers. Good luck as you go ahead with the exploration.
Around 2% of the land area is situated in low-lying coastal areas, home to more than 500,000,000 people. None of the most vulnerable countries is a high-income country. Accordingly, the risk for livelihood and infrastructure is high, leading to displacement and poverty as these countries are unable to adapt and deal with increasingly frequent damaging events. The estimated costs of coastal flooding for cities in 2005 was about 5% of global GDP. By 2070, these costs are estimated to double. Even high-income countries that have the capacity to invest in their required protective infrastructure have a huge extra bill to pay. The financial investment for low and middle income countries will almost certainly exceed their adaptive capability. Worse yet, small island developing states are extremely vulnerable to climate change in general. While they cannot significantly contribute to mitigation, they face a complete loss of land above sea level.